Very
Or
good.
no.
Yeah, very good. So here we are seeing one more important curve, that is rectangular hyperbola. What is the difference regular hyperbola and rectangular hyperbola? Regular hyperbola, you are saying eccentricity greater than 1. Okay. So what is the specialty of rectangular hyperbola?
Eccentricity is 2.
2.
Root 2
Root 2.
Eccentricity 2, sir, and A equals to B.
equals B is
No, no. Root 2 is correct or 2 is correct?
root 2 root
Root 2.
Root 2, sir.
Yeah, very good, very good. Root 2 is the correct answer. That means it's having specific eccentricity value equal to root 2, which is equal to 1.414.
4.
However, it is greater than 1 only, but it is having specific value. Okay. So in general, normal hyperbola or regular hyperbola having asymptotes. I will explain the concept of asymptotes. The asymptotes are not 90 degrees to each other, but with different angle. But coming to the rectangular hyperbola, the asymptotes are 90 degrees to each other. Okay, so we will see while solving this problem, we will see what is asymptotes. Okay, the concept behind that. Okay, now before that, uh, you see the problem. Are you able to see the problem on the screen?
Yes, sir.
Yeah,
Sir, yes.
a point P is 30 mm and 50 mm respectively from two straight lines, which are at right angles to each other. Here you read the problem carefully. From two straight lines. These two straight lines, we call it as two asymptotes. Okay, asymptotes. In case of hyperbola, we call them as asymptotes, two straight lines, okay, which are at right angles to each other, 90 degrees to each other. So whenever I say 90 degrees means ortho means 90, okay, and these asymptotes are known to be uh, orthogonal asymptotes. So even though if you see the rectangle, the sides of the rectangle are having 90 degrees to each other. So
Perpendicular.
that's why this parabola is having special name rectangular hyperbola. Okay, and previously we have discussed hyperbola, right? Whenever directrix is given, axis is given, focus point is given, uh, vertex we have located. Thereafter, we have generated so many other points, right? Here, uh, unlike that, he has given some other point like one point on the hyperbola. Okay, one point P. Okay, and it is having distance 50 mm and 30 mm from the two straight lines, as we have discussed. Okay, so on the hyperbola generally we are having so many points, right? Passing through all the points we are able to construct hyperbola, right? Here only one point, single point P is given. It is given 30 mm from the straight line, and there are two straight lines, right? One is at 30 mm, and the point is from other straight line at a distance of 50 mm. Okay, so now we are ready to construct the rectangular hyperbola. For that, what you have to do is, I told you the straight lines are perpendicular to each other. First you draw two straight lines like this. Can you able to make up these particular straight lines? Are you able to see this particular OB, OA? Can you able to see
Yes,
OB,
sir.
OA? These you can use dark pencil, HB pencil, 90 degrees to each other. First you draw OB. Okay. While drawing this OB, match your mini drafter scale to the border line of the drawing sheet. So already printed border lines will be there. You match one of the drafter scale to match the drafter scale to the printed border line. Parallel to that, you start on the drawing sheet somewhere OB. You need to draw OB line of any length, okay, with HB pencil. Similarly, tight the mini drafter knob parallel to this OB, okay. Automatically, the other mini drafter scale is showing 90 degrees, right? you can easily draw OA. Okay, that is the advantage of mini drafter. Okay, without mini drafter, please don't draw anything on the drawing sheet. Okay, it's a good habit to use the mini drafter all the time. Thereafter, what I said, these two lines are straight lines are nothing but two asymptotes, 90 degrees to each other. Now, a point is located such a way that it is 30 mm from OA and 50 mm from OB. Okay, you can even assume it is 30 and this is 50. But let me take this, the distance of that point from OA line is 30. Now you take your mini drafter, mark a 30 mm distant point, okay, and draw one vertical line parallel to this OA. Okay, thereafter, parallel to OB, on the vertical scale, you can measure a point at a distance of 50 mm. Draw one horizontal line there. Okay, that line is parallel to OB. These two lines are intersecting at this point, capital P. In this way, first of all, you need to locate the given point P. What we have to do? We need to draw two lines. One is parallel to OB at a distance 50 mm. One is parallel to OA at a distance 30 mm. Is it clear?
Yes, sir.
Yeah, I will show you the dimensions. So this distance, this horizontal distance is 30 to draw this vertical line, and this vertical distance is 50 to draw this horizontal line. Okay, these two lines intersecting at this point, capital P. This is the given point you can see from the problem. Okay, now the rest of the procedure is simply remember the steps. You can easily make up the curve. Okay, first of all, what you have to do is select any random points. Random points I told you, right? Random points means what? You can select a number of points after point capital P. After point capital P on the horizontal line, some 1, 2, 3, 4, 5, 6. May not be equal, may not be equidistant. Okay, you can select these points at different distances from this point capital P. Similarly, above the capital P, you can also choose some other points like this 1, 2, 3, 4. Now it is very important to remember this step. You join all these points, dots I have shown you with red. Okay, join all those red points to origin point. Okay, or intersecting points of these asymptotes. From O to you need to join all the red dots. Okay, now are you able to see the lines on the screen?
Yes, sir.
Yeah, maybe it is showing very light lines, but use all these lines must be drawn with 2H pencil. You also you draw with 2H pencil light lines. Okay, now since for example you after point capital P on the horizontal line, you see you concentrate on the first dot, red dot, and the horizontal line, one line is passing, right? We have drawn one line. That line intersecting this down below the P, one line is there, right? Down below the P, you will find one line. So that line is intersected by this inclined line. We have drawn O to first point, right? So somewhere it is hitting that line passing through P. So that point you need to identify. So from that point, you need to draw horizontal line, and from the red dot, you need to draw vertical line. I will show you. Here somewhere, the first line, you see, this is the first red point, right? From that point, we have drawn one line meeting the origin point. This is, I am calling it as some inclined line. That inclined line is intersecting one line passing through capital P, right? We have drawn already. So it is intersecting at this point. From that point, okay, you draw horizontal line, and from the dot, red dot, you draw vertical line. These two small lines will intersect again at particular point. This is the first generation point. Okay. So this is the first point we have generated. Similarly, repeat the same procedure. Now you go to the second dot. The second red dot we have joined already to O, origin point. That line is intersecting again the line below the capital P, somewhere here. Okay, somewhere here. You drop horizontal line, and from the second red dot you draw vertical line. Okay, I will show you like that. Any confusion here? Please tell me. Otherwise, the procedure is same. Completely the same. Entire problem is it clear?
Clear.
If you are having mini drafters with you, you better you draw along with me. Then you can finish up this problem. Similarly, you can proceed with the problem. Same steps. You would find 1, 2, 3, 4, 5, 6 points because I have taken six red points here, right? So I will get six intersecting points, or we call it as generating points to draw the curve. That means starting from P or passing through P, we have already done half of the problem. Okay. Now what about the upper red dots above point P? So same procedure. Okay, same procedure. Here again the point red point I am joining to O. Again the second red point I am joining to O. Okay, all these lines are intersecting this horizontal line left hand side of capital P. Yes or no? Yeah, are you following?
Yes, sir.
Yeah. Then
Yes, sir.
yeah, you just first concentrate on my first point here, red point above capital P, first dot. So I have joined that line to O, origin point. That line is intersecting the horizontal line passing through P at this particular location, right? From there, you drop vertical line, and from red point, you draw horizontal line. Okay, like this. Vertical line, horizontal line, vertical line, horizontal line. Okay. In this way, you could again find four more points. You can use now HB pencil passing through all these points. You can simply draw one smooth line with freehand in a single stroke. Okay, don't draw 2, 3 times. Okay, in a single stroke with HB pencil passing through P. Okay, name these intersection points as P1, P2, P3, P4. Okay, that is also good habit. Okay, note down all those points, and then you can use your HB pencil passing through these points. You draw one smooth curve. This I am calling it as rectangular hyperbola. Rectangular hyperbola. Can you make up?
Yes, sir.
Yeah,
Yes, sir.
Sir, should we draw this in a separate sheet?
yeah. Better you, because this is the special problem, and otherwise you do one thing. I already given one assignment, right? Parabola.
Yes, sir.
Backside of the first sheet you are drawing, right?
Yes, sir.
The side by side you draw this one also, so that we
Okay.
can end all the problems in a single sheet. Okay.
Okay, sir.
Yeah, there are only total four problems in the conic sections, including this one. Okay, as per your syllabus. So with the sheet number one, we are able to conclude this particular topic, right? Can I move further?
Yes, sir, you can.
Yeah. So thereafter, we are having an important again one more curve that we call it as cycloidal curves. Okay, I have given an introduction in the last class. Now, how to construct these things, I would like to explain. Again, I would like to share my screen. Okay, please wait. So there are again three important problems in these cycloids. First is simple cycloid, second one is epicycloid, third one is hypocycloid. So now I'm sharing my screen. Can you able to see the screen?
Yes, sir.
Yes, sir.
Yeah, I am reading the problem for you. Okay, a circle of 50 mm diameter rolls along a straight line without slipping. Draw the curve traced out by a point P on the circumference for one complete revolution of a circle. Name the curve. Draw the tangent to the curve at a point on it 40 mm from the line. Okay, so first of all, listen carefully. Thereafter, you can ask some questions. Okay. Now, the important data here, simple data. See, circle diameter is only given in the problem, right? And ask to draw one curve for one complete revolution. Okay. Only that is the given data. Now, you can note down roughly somewhere the given data like this. Circle rolls on a straight line for one complete revolution. That is the key note you need to make note down. And the diameter is given 50 mm. It is equal to, we can calculate, why we are calculating pi d? Why we are calculating circumference?
Circumference of the circle.
Because if you take a fixed point on the circumference, that point is tracing the path actually. I have discussed in previous class, right? If you take a cycle wheel, right? That one, if you take a capital P at the bottom of the circle or cycle wheel, which is common to the ground, okay? And if that point is rolling, okay, while the cycle wheel is rolling, right? If that point which is fixed to the cycle wheel also rolls, right? So that at different times of interval, that point is taking different positions, right? We are getting those positions as some generating points. Okay. Finally, we are getting the cycloidal curve. Okay. So asking to construct the cycloid, indirectly asking cycloid only. Okay. You need to understand by reading the problem, it is cycloid only. So asking to draw the cycloid for one complete revolution. One revolution, that point fixed to the circle travels a distance of pi d, 2 pi r circumference. For that reason, we are calculating this value. It is about 157.14, 0.14 you can neglect. If it is 0.15, you can round it up to 1.157.2. But it is only 0.14, you can neglect. Take your mini drafter, measure the distance 157 millimeter, means about 15.7 centimeter, 15.7 centimeter. Now, thereafter, what you have to do is, you need to draw, first of all, rolling circle, right? Which is given 50 mm diameter. What is the 50 mm diameter means? What is the radius? 25.
2.5.
Yeah.
25.
You need to take 25 mm radius with your compass. Don't take 50 mm with your compass. Okay. You need to read the problem carefully. Diameter is 50, radius 25. Draw one circle, which is the rolling circle. Okay. Now, here important. I will tell you. We need to divide this rolling circle also 8 parts, and the length of the point P, which is traveling for one complete revolution pi d. So this line, straight line, I have drawn. This is nothing but the ground. You can also say that this horizontal path, okay, on which the circle rolls is known as ground horizontal path. Okay, for one complete revolution, it is equal to pi d. Now, can you do this work? Okay, can you draw one circle, divide it into n number of equal parts? Okay, now how many parts I have done? 8, or you can do 12 parts also. Okay, better you take more number of parts so that you can draw the curve. You will get many number of points, generating points. If you take less number of equal parts, you will get less number of generating points. While joining the points, you will face some problem. That's why if you take 8 points, eight divisions or 12 divisions, it's very uh, suitable. Okay, good practice. Now you see how to divide circle 8 parts.
Taking vector 45 degrees.
Yeah, 360 by 8, 45 degrees. If you want to divide 12 parts, all of you do 12 parts. I suggest you go for 12 parts. Okay, but for explanation purpose, I am taking only 8 parts. Okay, then if it is 12 parts, 360 by 12, how much?
45.
40, no,
30 degrees.
30 degrees.
30 degrees. 360 by 12. Okay, 30 degrees. You can divide this into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, 11. Up to 11 you can divide. Okay, so first let me complete with 8 parts. You do that 12 parts. Okay, after that, numbering is very important. The rolling circle rolls right hand side, right? So it is rolling in the clockwise direction. Clockwise direction. But the numbering system I have taken in the anti-clockwise direction for convenience. Okay. So you follow this method. Capital P is touching onto the ground, which is a fixed point on the circle. Okay. Now P is at the initial generating point. P is the starting point of your curve, and somewhere it ends here. Okay, after traveling one revolution. That is the end point of the generating curve. It is the starting point of the generation. Okay. After this, the length pi d also we need to divide same number of equal parts. How you have divided the circle 8 parts. The pi d also you have to divide 8 parts by line division method. You know how to divide into 8 equal parts pi d. Can you do that?
Yes, sir.
Yeah, take your compass from P starting point. You draw 8 equal arcs. You draw 8 equal arcs. Okay. How many arcs I have drawn? 1, 2, 3, 4, 5, 6, 7, 8. Last arc, what you have to do? Join to the other end of the line. Other end of the line PD, pi d. Okay. So you will get one inclined line. Okay, match this line to one of your mini drafter scales. Parallel to that, you need to draw remaining parallel lines. Okay, like this. So what happened? So you will get this PQ, or you can say some PP line, horizontal ground path, is automatically divided into 8 equal parts. 1, 2, 3, 4, 5, 6, 7, 8. Okay. So what we have done? First we have taken rolling circle, divided 8 parts, PP length, pi d, divided 8 parts. Okay. Numbering system very important. Starting P at the ground. Okay. In the anti-clockwise direction, we have given the number system, which is opposite to the rolling circle direction. Okay. And exactly this is the center of the circle. Radius is 25. Thereafter, you draw so many horizontal lines like this, passing through 1, 7, 2, 6, 3, 5, and 4. You have got all these horizontal lines. And thereafter, you need to draw vertical lines from 1, from 2, from 3, up to the center line. Okay, you need to draw vertical lines like this. Are you able to following? Any
Yes,
difficulties?
sir.
Yeah. So this is the center dot, right? So up to the center line, you need to draw these perpendiculars. 1, 2 at the center line, from 2, 1 perpendicular, from 3, 1 perpendicular, like that. Okay. Now almost the problem is over. Okay. Now you take your compass. Take your compass. Set the radius always fixed. 25 is the radius, which is the rolling circle diameter. Okay, radius. Take 25 radius. Okay. Then, so initially you can name it as center C0, C1, C2, C3, C4. From 5, you have drawn perpendicular, right? You call that point up to the center line. That is C5, C6, C7. Okay. C8 is not required. So now you already taken right compass. Take the radius 25. C1 as center. C1 as this is the first center of your compass. C1 as center. Cut the first horizontal line. First horizontal line is a line passing through 1 and 7. We have drawn one horizontal line. Correct? You take C1 as center. Cut that line. Cut that line. It will be you will get that arc. One generation point you will get. Okay, somewhere here, somewhere in between 1 and 7, you will get one arc somewhere here. Are you able to see the screen? Yeah, please mute those who are not. Yeah, I am asking question. Are you able to see this arc in between 1 and 7? Center is C1 somewhere here. Take radius 25. Cut the first line 1 and 7. Pass the line passing through 1 and 7. Here you need to cut here somewhere. Okay. Now change your compass center from C1 to C2. Okay. Again from C2 with the same radius. Radius is always fixed. Okay. You don't change the compass radius always. Okay. That is constant. Only you change the center of the compass. Initially C1 we have generated one point here. With C2 cut the second line. Second line means second horizontal line passing through 2 and 6. Somewhere you will get that curve arc here. Okay. Now go to the center C3. C3 is the your compass center. Cut the third line passing through 3, 5. 3, 5, there is a horizontal line passing, right? So there you will find one more intersection point. Now go to the center C4 with your compass. Cut the fourth line. Somewhere you will get here. Similarly, to the right hand side also, again C5 is the center. Again 3, 5 is the common line. Okay. So 5 is also along the 3, 5 line only, right? So C5, fifth line. C6, sixth line. C7, seventh line. By doing so, you can end up with C7, and you already starting point is P, end point is also here. Starting like P, there is one more dead end point here. Okay. So we have generated 7 generating points. Okay. Passing through all these points with a smooth curve with your HB pencil, simply join the curve. Just identify. This is the cycloidal curve. Okay. Now I am giving you 1 minute time. You can ask any questions you are having. Anyone?
Once again, explain that curve, that arc once you explained, sir.
Yeah. So see, are you able to identify center C0? Okay, and C1, C2, C3. Okay. Are you clear about these center points?
Yes, sir.
Okay. Then you take your compass. C1 is the first center. Radius is 25. Cut the first horizontal line. First horizontal line is what? Line passing through 1, 7. We have drawn one horizontal line, right? So that is the first line common to 1 and 7. Okay. So from center C1, radius 25. Are you able to cut the arc here somewhere? So this is the first I am showing you my cursor right here. Are you able to see the cursor?
Yes, sir.
Yeah. Here you would get one generating point. Similarly, go to the center C2 with compass. With compass, go to center C2 and cut the second line. C2 means second line, C3 means third line, C4 means fourth line. Like that you remember. C2 center, cut the second line. Again radius 25 only. Radius never changes, okay? Only center changing. C2, cut the second line, line passing through 2 6. So you put your compass at C2 center, then just cut that line 2 6. Okay, you will get the second arc on the 2 6 line. You will find one more generating point. Like that, can you able to make up?
Yes, sir.
Yes. Yes. Is there any other question specifically? No questions? Yeah, one more important thing is like for any curves, generally we will have normal and tangent, right? So like ellipse, parabola, hyperbola, we have drawn uh, tangent normals, okay? Similarly here also, if you take any point on the uh, curve, cycloidal curve, we can able to draw normal and tangent also, okay? Let me explain for 1 or 2 minutes. Now I am selecting a point somewhere on the curve. Yeah, I have taken this point as my required point at which we need to draw normal and tangent. Take that point as Q. Are you able to see the screen? Here somewhere I have taken Q.
Yes.
Okay. So in the problem also he has mentioned at a distance 40 mm. So I have drawn one 40 mm height line. I have drawn one half mm line. So there, yeah, there I have taken that point as Q. After getting that point, take your compass again 25 radius, cut the center line. Cut the center line like this. See, I am showing you one arc, special arc here on the center line passing through 2 6. This is the center line. Okay, from the point, take 25 mm radius, Q as center, Q, I have taken point right on the curve, Q as center, 25 radius, cut the center line somewhere here. Thereafter, you drop down one vertical line onto the ground PP line, onto the ground PP line. So from this arc here, I have drawn one vertical line which is touching the ground. Okay, that point I am calling it as some M. Okay, from M I have to join that point on the curve at Q and extend further. This is the required normal or tangent. Anybody?
Normal.
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 Very good, normal. So you can easily draw the tangent at that point Q with the help of mini drafter 90-degree scale. You can use you can draw the tangent. Normal and tangent generally having infinite length. Okay, so you can extend. Don't normal also you can don't stop at Q. You can extend little bit outside the curve, and tangent also you can extend. Okay, like this. So these two are perpendicular to each other. If you don't get normal or if you don't get 90 degrees between these two, somewhere you have done mistake. Okay, again I am repeating. You select any point Q on the curve, take your compass, cut the center line somewhere here with help of compass, set the radius 25, cut the center line somewhere here from the given point Q, and from there you draw one vertical line onto the ground. Okay, you call it as point M. Join MQ. Fine, MQ. That is the normal. Again, you draw perpendicular.
Sir, in exam we need to write steps also.
Not required, not required. You show this sketch only. Okay, whatever I am showing you on the screen, you need to draw the entire sketch. Okay, that is the advantage of our subject. You need not explain anybody by writing down all the steps. Okay, there is no steps required to draw write on the drawing sheet. Only thing is you can mention the height given, the tangent point at a given 40 mm, normal tangent you have to show, some dimensioning like pi d 157 you have to write just down below the figure, and you can also write simple things like radius 25. Okay, so whatever I am showing you on the drawing the screen, only you need to reflect on the drawing sheet. Okay, don't write any steps. It's not required. Okay, any other questions?
No, sir.
If you remember this procedure, you can adapt for even next problem, that is epicycloid. Okay. Now here the cycle wheel is rolling on a straight path PP, right? Straight horizontal ground PP. Okay. But the difference between cycloid and epicycloid is, here you see PP is a straight horizontal path, right? In case of epicycloid, this PP is a curved path. Okay, on the curved path, this rolling circle is rolling without slipping. That is the only difference. Okay, understand? Here, all 1 7 line passing through 1 7 is a horizontal line, right? Line passing through 2 6 horizontal line. Center line is also coincides with 2 6, and 3 5 is a horizontal line. Fourth line is also horizontal line, right? But in case of epicycloid, all these 1 7 becomes 1 7 arc, okay, circular arc. These straight lines becomes curved lines or circular arcs, because the horizontal ground PP becomes curved path, curved path. Okay, then we will get the required epicycloid. Please wait, I will explain after some time. Okay, so in this way you practice this cycloid on your drawing sheet today. Okay, don't postpone this work for next tomorrow. So make it up. Okay, evening time you are having free time, right, after classes, after 4 p.m. Practice all these things on your drawing sheet with help of all the instruments. Okay, so here only this red curve must be drawn with HB pencil, and normal and tangent also HB pencil, and lettering and numbering is also HB pencil. Remaining lines, okay, 2H pencil. Okay, so this dimension line 2H pencil, arrowheads also 2H pencil. These perpendiculars, line division method, circle division method. Okay, drawing arcs, everything with 2H pencil. Okay, so remember this is our standard notations we follow. Okay, you need not mention mm. Don't write mm. I have shown you here mm, but don't write mm. By default, in our engineering graphics, all dimensions are in millimeters only. Okay, so wherever you write numerical values 40 or 157, keep it as 40 and 157. Don't write millimeters. Okay, so here I have written R25. I did not mention R25 millimeters. Okay, simply R25. So while putting dimension for radius, from center you draw one inclined line. So only one arrowhead, okay, you can take, that you write R25. That is the representation of radius. Okay. If you want to mention diameter, you extend that radius line and you can mark, you can take one more arrowhead. At the center, you can write diameter 25 or phi symbol, 5 feet 25. Okay, that symbol you have to mention. Previously I have shown you, right? So this is the entire picture of cycloid. So if you understand, you can easily draw the next problem, that is epicycloid. Okay, So before concluding this class, we are having one more class right after this. At that time, we will discuss remaining topics, remaining problems. Okay. Now, before ending with this, I would like to interact with you, ask you a few questions. Anybody there with me? Please respond.
Yes, sir.
Yes, sir.
Very good. Almost 60 students. Nice. Including me, 61 presented. Okay. Good to see you one more time. And I will ask you few questions. Can you switch on your video so that I can see your faces? Anybody there? Yeah, Varun.
Yes, sir.
Yeah, tell me. Uh, so for drawing cycloid, what is the data required? Data required you are expecting in the problem.
We need radius of the circle.
Yeah, that is sufficient. Okay. Very good. Sushmita, if it is given for one revolution means what? For one revolutions means what?
Means the circle roll only one time.
Circle rolls
Once.
once. Okay. And if you take any point on that circle, it travels what distance?
The circumference of the circle.
Okay. Yeah. So Abhishek,
Yes, sir.
yeah, what is the formula for circumference?
Pi d.
Oh, you are getting easy question, right? Okay. Then I am not able to see any faces. May all are in switch off condition. So I will ask you then at least you switch on. I call your name.